Yes. Our objective for today, I can solve for the missing side of a right triangle using the Pythagorean Theorem. Let's read together. 1, 2, 3. I can solve for the missing side of a right triangle using the Pythagorean Theorem. And Luca said, what are we having the pop party on, Mr. Q? What would you think, Luca? That's what you were thinking? What was the other option? That's the Pythagorean Theorem. Julian for Presidente. No, it's going to be on Pythagorean Theorem. So let's move on. So we don't need a Fourier model because we know what right triangles look like, yes? And the definition is a triangle with one right angle or a 90-degree angle, and they look like this. None examples. We said hashtags were a triangle, 190-degree angle. Okay. Now, yesterday, 2 days ago, as we were going through this, I was going step by step, mentioning the step, but I never really wrote out in words the step. Is that correct? Okay, so I want you to write steps, please. We're going to come up with the steps right now. Make sure we know and we have all our process. Okay? All right, let's see. Should we move forward this really quick? Just to kind of like prompt your noodle. Don't copy that. But let's think. I gave you this problem the other day. Now we're going to focus on steps, not the work. And I said, okay.
The work is steps?
No, the steps is explaining the process. The work is using the steps to show the process. All right. So, looking at it, I said, given this problem, what do you think would be our first step? Tell your neighbor, please. Mel, what would be our first step? That is correct. Write the Pythagorean Theorem. Okay, so picture that. We wrote it. And I said, now that we have it written down and you have that problem, what would be our step 2? Tell your neighbor, step 2 would be what? All right, Mel. Substitute values. Okay. So once we substitute values, we're ready to do what? Tell your neighbor, please. What is the third step? Let's see. Step 3, Mel. That is correct. Simplify. We're going to simplify as much as we can. Okay? And of course, our last step for most of these, if not all of them, tell your neighbor, what would it be?
Solve.
That is correct. Solve for the variable. Sometimes we write solve for x, but in this case, sometimes they're going to give us a different variable. Okay? So, just to recap, you don't have to copy this. I'm going to do this one using the process and see if it's true. Write the Pythagorean Theorem. A squared plus b squared equals c squared. Substitute values. 8 squared plus 15 squared equals c squared. Simplify. 64 plus 225 equals c squared. I can still simplify. 289 equals c squared. And lastly, solve for the variable. How do I solve? Well, I need to get rid of that squared. Square root. Therefore, 17 equals c. Why didn't I use negatives? Because now we're involving distances. So this is 17 centimeters. Okay? Tell me the first, how come you are with that so far? 5, 5, 5, 5, 5, 5, 4. Okay? So we're there. So from there, I kind of brushed through this one, yes? And then from there, we got to one using the coordinate plane. You guys remember that? Well, we need to plot at 2 points, da 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 da, and I left you home plate 10 problems of those to get practice. All right, where I want to get to today is to one of these. Hold on. Before, you don't have to copy this. We're going to be doing applications to word problems. And if you notice here, they give us an illustration, but who notices the right triangle here? Yeah, you see it, right? And pretty much that's what we're going to be doing with word problems. Well, let's start by practicing more of these. Copy this one, example 1B. Now, in the other class, somebody said, Mr. Q, can I switch the triangle over because I don't like it like that? I said, no. Yeah, you need to leave it as is so you can get used to the different views of the shape. Now, for some of us that are going to start struggling with some of these geometric figures, heads up, next year if you're in geometry, make sure you're in tutoring from the beginning of the school year. Please, pretty please. This is geometry. It's both. It's algebra and geometry. Yeah, but next year you're going to be looking more figures like that. So it says, example 1B, use the Pythagorean Theorem to find the missing measure. We're going to do this one together. And the triangle given is there, and then I'll talk it out with you so we can see exactly what we're looking at. So I'm going to zoom into the figure. Here it goes. All right, let's follow our process. Everyone, step 1. Write the Pythagorean Theorem. A squared plus B squared equals C squared. Now, before I go to step 2, which is substitute, let's label this one because some of us are having a hard time seeing which one is which. So here we go. Whenever they start switching you the triangle, I want you to label the sides to make sure which one corresponds to which. So, what did we say? That the 2 sides that make the 90-degree angle, does everybody see the 90-degree angle here? Those are my legs, which means one of them is A, the other one is B. Do they have one already labeled? Yes, B. That means this one is what? This one is A. And obviously, if this is A, this is B, that means this one has to be C. Does everybody see what we're doing? All right, now we can substitute. And we're doing this one together. Here we go. A is 5 squared plus B remains the same, so that's B squared. And what is C? 13 squared. Okay, we're good? All right, let's simplify. What is 5 squared? 25 plus B squared equals 13 times 13?
169.
169. There it is. All right. Can we simplify the left side anymore? No. Can we simplify the right side anymore? No. So what is our last step? Solve for the variable. So I'm going to circle my variable so I can focus and see and get rid of anything else. So what do? Minus 25 to each side. We get B squared equals 169 minus 25, that's 144. Am I done? No. How do we cancel this squared? Square root, B equals. Now, before I answer anything else, do I write plus minus? No. Tell your neighbor why not. That is correct. We don't do the negative because we're dealing with distances. We don't deal with distances and negatives anymore. So this will be positive 12. So we label this. This side measures 12 centimeters.
Mr. Q, I just noticed something.
What?
You got your green screen fixed.
My green screen? You barely noticed it? Wow. All right. We got this, yes? All right, let's see. You're going to do one by yourself. Example 1D. Example 1D. Let me zoom in. There it is. Example 1D. Copy that triangle and solve for the missing variable. Ready? Go. All right, let's see. Help me with this one. Step 1, Mel. Write the Pythagorean theorem. A squared plus b squared equals c squared. Continue. Substitute value. So which one is A? 3 squared. B? B squared. And C? 5 squared. Continue. Step 3 is? Simplify. So this is? And now we solve. What do I do? B squared equals 16. So, centimeters. Hands, have you got that? Okay, we got these, yes?
Yep.
All right. Let's crank it up a notch.
Yeah.
Let's go. Copy this one, please. No, just the black text.
Okay, got
The other stuff, no. It says, a square field has sides of 75 feet. About how far is it from one corner of the field to the opposite corner of the field? Round your answer to the nearest 10. Copy that, please. There. Here it goes again. It says, example 2A, a square field has sides of 75 feet. About how far is it from one corner of the field to the opposite corner of the field? Round your answer to the nearest 10. Therefore, if it says a square field, what would be the first thing that you would do? A square. That is correct. Draw a square. There it is. Nice and straight like mine.
Except we can't draw a straight line or square. Unless we have a ruler or an index card.
You can do it. I have faith in you guys. All right. What else does it say? Let's label it. It says a square field has sides of 75 feet. Now check this out. I'm going to write 75 feet for this side. Do I need to write it on each of the sides? No, check this out. For geometry, in order to indicate that all sides are congruent, what's the key word? Congruent. That's probably a word that you're going to start hearing more in geometry, which means the same measurement. Congruent, same measurement. To indicate that they're all the same measurement, check this out. I label this one with 1 dash. So if this one has 1 dash, guess what? This one, and this one all have the same dash. That indicates that all the sides are congruent. Yes. Okay. Now, look up. What if I did this? Pay attention, please. Look up to the screen. What if I did this? Don't copy this, but pay attention. Remember what that would mean.
That would mean that that's what you
That is correct. That they are not all equal, but this one is equal to this one. It's congruent, and this one will be congruent to that one. That's how they indicate when the same measurement applies to another side. Okay? I'm sorry?
The first line is like the water and the two lines that will connect to make a bridge over the water.
Whatever. All right, here we go. Next, let's continue labeling. It says, about how far is it from one corner of the field to the opposite? Now, before you start labeling, let's look up. Whenever they're talking about a corner, I'm going to start, let's say, with this one. And then there's two possibilities here. These corners or this one. Now, check this out. These corners are not opposites. When we have a point here and it's on the same segment or on the same side, those are called adjacent corners. What does the word adjacent mean? Next to. So what are these adjacent corners? So are we talking about adjacent corners? No. We're talking about the corner that is opposite. What is the corner opposite? This one. which means we're going to sketch a line from here to there. And what do you guys notice? Exactly. So label your right angle. Once you label your right angle, that tells you which one is A, B, and C. So Fatima, which one do you want to be A? This one? Okay. So which means this one is what? And everyone, what does this side measure? 75 feet. That is correct. So with that said, Fatima, what do we label this? C. Does everybody see what Fatima said? All right. So let's use our process, and the rest is history. We know the process. Yeah.
Yeah.
All right. So step 1, write your Pythagorean theorem. A squared plus B squared equals C squared. Next, substitute. So then I write what? 75 squared plus 75 squared equals C squared. 75 squared is 5,625, is that correct? 5625 equals C squared. We're still not done simplifying, so this is 11,000? 12,000? 12,050?
Yeah. Yeah.
Isn't it?
Yeah. 12,500.
I'll wait for you guys.
It's 11. It's 11.
Charlie, what'd you get? 11,250.
You would have got that eventually.
All right, good. All right. So then at the end to solve, we do the square root, and I'm going to do an approximation because they want us to round to the nearest 10th. C is approximately, and guess what? I'm going to use my calculator. What?
You said no calculator.
What are those? Well, for this one, since we involve big numbers, the square root of 11,250 is approximately 106.1. 106.1. We label that here. So this is 106.1 feet. Are we done? No, this is a word problem. So tell you what's the last thing we need to write. A statement. So we're going to write, it says, about how far is it from one corner of the field to the opposite corner of the field? So we're going to write, it is approximately 106.1 feet from one corner to the opposite corner of the field. 10Q. Tell me, listeners, how comfortable you are with these? Yeah, it's fairly simple, right? All it is it's sketching our illustration and labeling stuff, and then just applying the Pythagorean theorem. Yes, sir.
Just trying how much I'm calculating.
Okay, good. All right, look at this next problem. Don't copy it. It says example 2B, and it says a rectangular field has a length of 100 yards and the width of 33 yards. How far is it from one corner of the field to the opposite corner? So in this case, we would draw a what? A rectangle. So don't copy this. I'm just going over it just to make sure that everybody sees what I see. There it is. The width is what? 33 yards. And the length is 100 yards. Now watch.
Football.
This, to indicate that this measures the same as this, what would I do?
That line.
To indicate this one measures the same as that?
Line.
That is correct. And that's how it's applied. And from there, you get the opposite corners, like from here to here, you draw your line, and the rest is history. Got it? All right. And let's go to the last problem. Example 3A. Copy that, please. Tell whether the given side lengths for a right triangle, tell whether the given side lengths form a right triangle. 12, 35, and 37. Copy that, please. All right, here it goes. Let me go back to the previous problems that we did. This one, this one, this one, and this one. What did you guys notice? That we were all missing a side, and we needed to solve for the side. So that means we used the Pythagorean Theorem, and we applied it, and we solved it. In mathematics, that's what we call applying the Pythagorean Theorem. But then we get to this problem. And they give us these three. Are we missing any sides? No. This is what we call applying the converse of the Pythagorean Theorem. What does that mean? Going backwards. So what do? Step one will always be the same. We write our Pythagorean Theorem. A squared plus b squared equals c squared. Step two will always be the same. What is step two? Substitute. But here's a dilemma. Look up to the screen. Now we have three different numbers. How do we know which one is which? Think about it. Talk to your neighbor. How do we know which one is which?
That's the A is always left, B is always left.
Okay. I hear interesting conversations, but here's the end of the whole thing. The end of the whole thing is that you need to make sure you identify first the longest side. What is the longest side? C, which is what? That is correct. So that one is C. Does it matter what we label the other two? No, as long as we have our longest side. But just to keep it organized, I'm going to start with the smallest one to be what? A. And the other one?
B.
And now we substitute. So this is 12 squared plus 35 squared equals 37 squared. And you're saying, interesting, Mr. Q. So we're not solving for anything. No, we're not. So look up. Third step is the same. Is what? Simplify. But since we're not solving for anything, we need to answer the question. Tell whether the given side lengths form a right triangle. Think about it. What would I get at the end to let me know that these are part of a right triangle? Talk it over to your neighbors. What do we need to get at the end?
Let's say equal. And 4 and 5 equals over.
Okay, let's see. Marissa, what would we get at the end to let us know that it is a right triangle? Close. Luca? Equal. This side has to be equal to whatever we get on this side. So, I want you to continue, simplify it, go all the way down to here and see if one side equals to the other. If it does, then it is a right triangle. I'm going to help you out on this one. I'm going to say 144. Oh, you're welcome. Yeah, you're welcome. No. Let's see, 35 times 35. What'd you get for that, Jason? 1225. All right. How about 37 times 37? What'd you get for that? Fatima. 1,369. Okay. Are we done with this side? No, we still need to simplify. 144 plus 1225 gives me 1,069. 1,369. And what is on the other side? 1,369. Are they the same? Equal? Yes. Well, guess what we're going to write? Yes, it is a right triangle. Thank you. So therefore, when will it not be a right triangle? When you simplify and they're not equal to each other. Obviously, right? So for tonight, not fortnight, our home play is a play sheet on Pythagorean Theorem. So make sure you grab one on your way out. It's over here. Good one, guys. There is tutoring. If I don't see you, enjoy your home play. See you guys tomorrow. Bye.